Today's stereochemistry, and I know in 20.3 it was perhaps not your favorite, so we're going to apply it to some biology. I see the advantage of this as being that I tried to front load a lot of it, so you've seen a lot of this stereochemistry before, so hopefully it doesn't all come as a shock and awe moment, to quote, someone else. You might recall that isomers come in many flavors. Remember this? Okay, so isomers are things that have the same chemical formula but different structures. And the first branching point we took was structural isomers. Can someone give me an example of structural isomers? What do you got, Brendan?
I was going to say propanol, propane.
I don't know if you, okay. Fine, we'll do both of these. You did butanol too? You did propanol, but we don't need. Just for, being a completionist, I want to get off some of these other problems for a minute. I admit I didn't draw any hydrogens. I admit I just don't care right this minute. But structural isomers are when we change the connectivity in a molecule. And because I got these two great examples, I decided to give you the third one as well. Audrey's changed the branching on the carbon chain. Brecken's changed the position of the functional group. And mine changed the actual functional group. So when we learned functional groups, we talked about how ethers and alcohols or ketones and aldehydes or whatever were functional group pairs. So those are structural isomers, and I hope they feel easy. How would you tell those apart? No, not so much naming. Like, what tool would you use to tell, say, the bottom ones apart? NMR would work for any of them. The bottom one's different functional groups. We have like a maybe easier. IR. Okay, so I'm hearing some general IR would help here because the OH has a pretty characteristic absorption or transmission, whatever, around 3200 that this one would have, that this one would have, that this one would not. But here we would have similar IR spectra, so we would have to go to either mass spectroscopy or NMR to tell them apart. You guys jump to NMR because it's so fantastic. I support that. Structural isomers. The opposite of a structural isomer is a stereoisomer. That's when we have the same connectivity, but somehow the shape in space is different. And so we decided to, break that into some categories. And we had conformation versus configuration. Conformational isomers were just things that had free rotation that allowed for different shapes. These interconvert regularly. So if you had a bottle of dichloroethane, 1,2-dichloroethane, I have a sigma or single bond between the carbons. And so that head-to-head overlap of the sp3 hybrid orbitals allows free rotation around this bond. I have the two chlorines both occupying the top of this molecule. So if I gave you a Newman projection of this molecule, you would see the two chlorines are what we refer to as eclipsed. This would probably be a slightly higher energy conformer than if the chlorines were opposite each other in a staggered or anti-position. I don't think you need to know the vocabulary. I think you just need to know conformation comes from free rotation. There are really minimal differences in energy, like 5 kilojoules per mole as it goes around. I think it'd be a fun math IA, but I don't think it's difficult enough to be a math IA. So, interesting, but maybe not that interesting. Configurational isomers are going to have to do with, we're going to have to take this thing apart and put it back together differently to change the molecule. And here we're going to have two classes. We're going to have things with double bonds or rings. That is things that prevent rotation. This is where we got E and Z, or cis and trans. And we're gonna have, you know, optical isomers. I don't know what to say. This is where we're gonna have D and L, or R and S, maybe even alpha and beta. This is where the fun came. So double bonds and rings. We said that because there wasn't free rotation around one of the bonds, there was a fundamental difference between cis and trans fats, but also between this molecule and its brother. While they might have similar chemical properties, presumably both of them would undergo addition reactions, they would have different physical properties. This one has a dipole and this one does not. So they would have different melting and boiling points, for example. Because two of these groups are the same, they were both hydrogens, we could talk about them being cis or trans with respect to each other. If we put on three different groups, you guys can argue that's still cis and trans, but let's pretend I did better. How can we decide how to call these two things? We're going to use E and Z. So E and Z is going to look at the biggest atomic number attached to the carbon. So here it's bromine, atomic number is 35. Here it's chlorine, atomic number is 17. Here it's bromine, atomic number is 35. Here it's chlorine, atomic number is 17. So again, I'm comparing these two, circling the biggest, and I'm comparing these two, circling the biggest. If they match, I look at the things attached to it. Here they're on the same side is Zusammen, or Z, opposite side is Entgegen, or E. So the dipole here is probably going to face the same direction because bromine is less electronegative than chlorine, but this molecule would also have a dipole now because bromine is more electronegative than hydrogen, so we could put in something. They would still be different. Fair point. I think the part that's going to be most new today, because I think you've mastered cis, trans, E, and Z, is going to be the D and the L. They stand for dexter and levulo, and they have to do with chirality. So I picked up my hands, because chiral comes from the Greek word for hand, to indicate that there is going to be some change in how they rotate plane polarized light. We're going to have an sp3 hybridized carbon, and 4 different groups around that sp3 hybridized carbon are going to give rise to non-superimposable mirror images, which we refer to as enantiomers. There are 20 amino acids in our data booklet, and 19 of them are in fact optically active or exist as enantiomers. So this looks like alanine to me. Alanine's R group is this methyl right here. When we want to demonstrate that there are 2 isomers that are enantiomers of each other, we must draw them with this dash wedge notation. On paper 2 at least. We draw a faux mirror in between them. And then we sort of question if they did a good job. I don't love the job they did. And we show that they are reflections of each other. So you are meant to know at this point in your life that you are made up of L amino acids. But if you really looked hard at peptidoglycan, really hard, really were interested in this story, when you're talking about Gram staining, you would have seen there was D-alanine in the linkages between those like long sugar. No? You know what I'm talking about or not?
We didn't go back there.
Want to see more of that? So that's peptidoglycan, which I know you guys have been playing with for a minute in that other class. So you have beta 1,4 links of sugars going this way, but then going down in between the layers of sugar, you can see D-alanine and D-glutamine. Apparently penicillin does something special to that D-alanine. You don't have any in your body, but it does occur in organisms. The only difference, again, being the chirality at that center. The reason I care so much about this is completely unclear.
Is there like certain like chemicals that are like harmful to like insects and all that that are not
I think that, I mean, yes, but I don't know if insects are different enough. But when we talk about chiral synthesis or asymmetric synthesis, I think we are targeting the chirality of molecules that we possess that might be different from the chirality of other stuff. Yes. So I know you're asking yourself the question, how on earth would I ever know if I had a D amino acid or an L amino acid if they drew one for me? Gotta be asking that question, right? Okay, thanks for asking. What I need you to do is I need you to imagine that molecule and I need you to rotate it such that the hydrogen is directly behind the carbon. So in this case, I'm going to rotate it like this. So the carbon and the hydrogen are going to go this way. So the hydrogen is going to be due back. And when that happens, this CH3 that used to be here is going to come up. And the CH3 is going to be up here like this, coming out toward you. And this COH is going to be like over here, perhaps. And this NH2 seems like it would be over here. And in my picture, I guess they're all kind of coming toward you. Did I do okay with the rotating this? I'm just trying to flip it like 90 degrees. Okay, so what I'm going to do next is I'm going to give these things some nicknames. I'm going to call the carboxylic acid, I guess, the CO. I'm going to call the R group R, and I'm going to call the amine N. I spelled out the word corn. We call this the corn method. I'm going to look at corn, and corn is counter or anti-clockwise. The fact that the word corn is anti-clockwise, so it makes this levulo, or the L amino acid. God, I love my job. If we look at it over here, we're going to again put the hydrogen directly behind. When we do that, the methyl, or the R group, is still going to be up. The NH2 would be on this side, and the Q would be on this side. Or again, in my new nomenclature, I would have a CO, an R, and an N. Oh, it's clockwise. It is dexter, it is right.
So, in the elemental acid, when you flip the methyl and the hydrogen 90 degrees, is that like how it always is supposed to be? Like,
It doesn't, like, the only rule is that the hydrogen is directly behind the carbon. It doesn't actually matter where the other three are in the tripod, just that the hydrogen has to be at the back.
so that why you move that one to be make it behind and go like out?
Yes. So again, the corn method tells us the difference between D and L. All of the amino acids in U are L.
Where's the hydrogen and the D?
It's like directly behind the carbon. I just tried to draw it more simply. I don't know which method looks prettier to you. I felt like the one on the right was a little bit complicated and the one on the left was, this is not how you would draw it? Oh. No, me neither. So you're saying if you had to draw an amino acid, that's not how you would have approached it? Me neither. I think it's kind of weird. Right to Pearson.
What does that stand for?
Levulo. So the words D is for dexter, meaning right, and L is for levulo, meaning wrong. if you were a super cool kid, you would know that a chemist would refer to glucose as dextrose, and might refer to fructose as levulose, using those words, but.
Why is the CH3 on the D one not coming out? And instead it's like on the plane.
In my picture?
Yeah.
Because I was just trying to simplify the picture here.
Oh, okay. I thought it was different.
So, no, they were meant to be the same. I was showing you two different ways I would draw it for myself to figure this out. So here I was trying to like respect the 3D-ness of it, and here I was just imagining that I flipped it behind, the CH3 went up, this stayed on the right, this stayed on the left, so I was just, like, I'm not gonna get any points for this artwork,
Okay.
as opposed to all my traditional art where I know you guys think I should be in the art show today. 6 o'clock, Midtown. You're going, right? What?
Is it not a village?
No, it's in Midtown.
Yeah, I know.
Jazz band's playing. The cool kids in the jazz band, not my kids. So he's not in tan bands. Tan band's playing. That distinction is subtle but real. So Ronnie is you probably call him Ronak or something equally. How do you say his name, Chef? How do you say it? No.
It used to be Tommy's bed or
It is
It used to be Tommy's bed, now it's Tan bed.
Yes. Any questions about that being cis? We talked about this when we talked about lipids. I did that on purpose because I knew this day would come someday and that I was going to want to not spend too much time on it. So this was with purpose. You see how that's trans? Trans fats are bad for your heart. Cis fats are naturally occurring. Cis fats are liquids. Trans fats are solids. Margarine, folio. You can hydrogenate a fat. You hydrogenate by, adding a hydrogen across a double bond and making it a saturated fat. That would make an oil turn into a fat, if you like, or make an oil, a liquid, turn into a solid. Because the packing efficiency would go up. It increases shelf life. They used to make Oreo cookies taste better, but now decide all this is poison for us, and Oreo cookies taste poopy, and all the joy in life is perhaps gone.
For the purposes of like the paper strength, like we need to know like how like the synthesis bad because like the LDL. I don't know if I don't know if this is less, but like acid, how it can like take whatever.
How it can, I don't even know where you're going.
How's it like unhealthy? Like how's it trans fat?
Bad for your heart, period.
Oh, that's all.
Causes heart disease. That's what I'm gonna say.
Because I was confused about the way that it was sponsored.
We have simple 1-mark answers to that question. Heart disease, obesity.
Question, is PD palladium?
PD is palladium. So we talked about carotenoids last time. Remember that? Good. I found an interesting question that pertains to this that I liked in the textbook, and so I thought I'd give it to you for a second of you thinking instead of me pretending I know what I'm talking about. Lycopene is found where? Lycopene. Prostate health, that's why we take lycopene. Yeah, you don't have one, but it's associated with prostate health. Like, they exist, just not in you, but they're important. Just perhaps not for you.
Yeah. Yeah, exactly. Exactly.
It is true.
That's not video.
So they're colored.
There's only one way to find out.
Lycopene is in tomatoes. You can take, like, if you take a man's multivitamin, which again, I'm suggesting that some of you may not do at this point in your life, or ever, they frequently contain lycopene because they're associated with prostate health. But this is the molecule, and Karthika already told you that there's an alternating chain of double and single bonds, and that brings rise to its red color. It is the red pigment in tomates. Did you know that if you expose them to bromine, it turns yellow? Could you explain that to me? Not pH. An addition reaction is going to occur. Fair enough, Randy, you win.
Does it act as like a
What?
You're coming back.
It's an addition reaction. This is a whole bunch of double bonds. So undergoes addition. What is addition going to do? It's going to saturate it. And so let's say it saturates this one. What happens to my box? If my box gets shorter, what happens to my energy levels? And so this should now absorb higher energy light. It does. It absorbs violet instead of green. But it's just a really nice question about addition reactions that didn't have to do with saturated fat, but did have to do with last time. I thought it was a good non sequitur. Okay, I'm teaching biochemistry. I think I can admit that prostates exist.
How about fun fact? Trans guys can develop prostate tissue in the vaginal flux.
Really?
There's my front order.
Fun fact. Okay, I feel like we're missing something here, so we're gonna have to insert. Number one, I drew you a Newman projection today for joy. The Newman projection, as in Carl, is this picture looking down a single bond. I don't know how many N's are in Newman, so I'm going with one, and one of you will Google it and correct me if you care.
I think that's correct.
This has to do with conformational isomers, and it's not a big deal. The next one, again, I don't know that anyone's going to be like, yo, draw a Newman projection with no hint as to what they're talking about, but I just want you to keep in mind that there are three. Is going to be a Hayworth projection. Actually, I don't think there's a Y.
Oh, no, no.
La la la. What am I trying to draw, but poorly apparently today? That's right, I have done my best to draw you a molecule of glucose. What does this like try to show clearly-ish? The ring structure of a sugar,
Position of the O's.
where the OH's and H's are with respect to the sugar that's not planar, but we're pretending it's planar. It's to clarify sugars. The third and final one is known as a Fisher projection. You did not know that my grandmother lived on 500 Fisher Street from 1926 until she passed away approximately 2009. A 500 square foot house with one bathroom in which she raised 5 children. Ooh, tight quarters. Fisher is spelled with a C. I'm gonna get one right. And Fisher projections also have to do with sugars. There's one drawn on that board. Again, Emma's not gonna get a point for knowing there's a C in that word, but you wanted to know my grandmother's address. She don't live there no more.
We'll put it on her back.
Okay. Real close to LA, just north. Do we have a molecule we like? Oh, we'll draw alanine again.
It's aesthetic.
Do you guys know Sonia Kotian?
Who's that?
She's a graduate of the Village School. She's at UT. She has a very lively Instagram account. She was a very mild-mannered girl in high school, and now she's a bit of a party girl at UT. What?
Oh, that's her sister, Sakshi Kotian's sister.
Yes?
Yeah, oh yeah, okay, I know.
She got away with drawing the picture we're about to draw on paper too. She found it like an easy way to earn marks on something. So I'm telling you a secret that I've tried to keep from you. Everyone okay with this being chiral?
Yes.
Do you want to tell me if it's D or L? I'm not sure.
Wait.
It's a
So like I'm standing over here, this is clearly where Margaret's standing. She's like, okay, the H is behind me. I got the CO, the R, and the N. It's going backwards around the clock. So this appears to be levuloalanine.
What's Lamila?
Oh.
I love it. What I'm going to try to do is I'm going to try to rotate this molecule correctly. I'm going to rotate it by putting it in the shape of a cross. Happy Easter. Yes.
This might be a dumb question. What's the point of the Newton drawing? Because I don't see what it's good. It's staggered.
Oh.
It's like showing how like one set of thingies can be like different and they rotate separately from each other.
It says furtherance.
That's me. I'm the furthest one.
Oh, Mahut, there's a really pretty big pencil. I feel like you would enjoy this very much. I don't know, it's just some random pink pencil, and
I don't
this
know.
color really suits you. It's even got.
It's supposed to
Disney
show
on
you
it.
that as we took
Also-
dichloroethane, if the two chlorines are trying to be in the same point of space, they're going to bump into each other. The energy is going to be quite high. If the two chlorines are actually opposite each other, the energy is going to be low. If the chlorine is like here and here, oh, not there, sorry. Here and here, they're relatively far apart from each other. So it would be called staggered from each other. That would be like a local minimum, but not the global minimum. If they are eclipsed, but it's an H and a Cl, an H and a Cl, and an H and an H, that would be a local, but not the global maximum. And that's why I say it's like a curve-fitting math IA in sine functions. If you think it'd be fun, but it doesn't really seem all that fun sometimes. God bless. I just don't want to tell you the wrong answer. I hate failure.
How do you feel about that?
Okay. So we're going to draw in the shape of a cross. In the shape of a cross. I didn't lie about that. But in that cross, what I'm going to do is I'm going to have the two arms that are coming towards you along the horizon, and the two arms that are going away from you up and down. So if I were to rotate this molecule kind of that way, so that I had a CH3 going back, and an H going back, this NH3 would be coming toward you, and this Q would be coming toward you. You can draw it like this. Heard my name.
Dr. Hennessy,
Yes, ma'am?
are we all going for this walk? Like, my class said, yeah, we have to go for this walk, I don't know, for 15 minutes.
There's a wall.
I don't know if you received anything, they know better than I do.
I mean, I know that Finna did it yesterday, but that's the only thing I know about the walk. We're supposed to go walk now?
That's what they were talking
Is it something about walking?
about. The only thing
Vespa's putting on a walk around the world. Yesterday, Finna did 960 laps.
Can we walk?
I think that's like all the kids walking once, not one kid walking 960.
Laps?
Wait, what lives? Wait, what?
I was like,
No, one's at each person. That's still a lot of laps for all of them to do. Cumulative, that's still a lot of laps. There's not 950 kids. High school is like 1,000.
I don't even, like, I'm just gonna text
Or
Miss
no,
Conroy.
not even. No, high school has, it's like 170 something per grade. It's like it's between 170 and 210 per grade, right? Multiply that by 4, it's like close to 1,000 or 1,000. And Fina's maybe smaller than my school. I mean, that's not bad.
Is that a
I feel
choice?
like they're really tiny, so they can take up more space.
That's a decision. Okay, so what do you notice about this fun Fisher projection? What do I not put at the center? I have to draw it as a Swiss cross, whatever, same length. And I have to put the four things on it. But what this conveys is that these are coming towards you and that this is going away from you.
So then on the we're never gonna have a line that
If you're having trouble visualizing this, keep having trouble. Yeah, just keep having trouble. I'll try to get some models out next time. Really, I don't know where they are right now.
What is that type of like projection called?
That's the fissure.
Oh, the cross.
So the fissure is the cross.
So then what's the one below fissure?
So that's that's dash wedge.
That's
That's our typical 3D drawing. So if I was in paper 2 and someone said, show me this one's enantiomer, I would draw the dash wedge, I would draw the line, and I would draw the opposite dash wedge because I want to give full marks. But our friend Sonia, who has a little sister who's still here, she would draw this one because she knew how easy it was to draw.
So you just draw the.
And then the line, and then it's reflection.
So you don't have to draw the one on top.
So you don't have to draw what?
You don't have to draw the one above it with the.
This will get you the mark on a paper 2.
Even if it says do the dash wedge.
If it says do the dash wedge, Mohab, you have to do the dash wedge. I
But
apologize.
like, so if it says give me the enantiomer, they don't have to. They don't specify dash wedge.
They say show that they are enantiomers. You can use this, but only the people who do the biochem unit are familiar with this notation. So it's like an advanced thing. That's why I don't sell it very hard, because I want to make sure you get the point. So certainly if you know how to draw this picture, it's the better answer, but this is the easier answer, especially if we're struggling. Audrey's all in for this answer. So if someone says draw 2 enantiomers but doesn't specifically ask for dash wedge, you can use the Fisher projection. The Fisher projection implies that these 2 things are coming towards you, that those 2 things are going away from you, and it is different than this structure that is its mirror image. So you do actually have a choice of which you want to draw. And strangely, when we draw sugars, we almost always use this notation. So if you were to look at the structure of a straight chain sugar, I want to burn all of these notes. Why do they never have what I want? Stop enjoying yourself. We traditionally draw it like that. You see how that's just that Fisher projection? We typically don't draw the carbon in the middle. It's purposeful. It's because we're trying to tell you that these 2 things are coming towards you and that these 2 things are going behind you. Like we are showing you the stereochemistry in that picture. It is not an arbitrary picture, and it is not a Lewis structure, though I have never admitted that to you before. Now some people misdraw it with the carbon in there, still trying to draw this notation, and so it's like a mixed notation moment. It's not really super elegant. It's accepted for sugars because everyone knows what you mean. That's kind of weird, gross, makes me uncomfortable.
Can you explain it? So all of the problems, all of them are going.
These 2 are coming towards you, and these 2 up and down are going behind you. Look at some molecules. Let's have it. I'm just gonna make this class never ends. I haven't been able to open that for days, guys. Someone wants to make me some glucose, feel free. Let's see if we can put it in D-glucose Fisher projection. I can get a bigger one. Everyone's going up for this activity. I'm Raji.
Why are you discriminating me?
No one's discriminating against you.
No, I'm sorry. I'm not just saying.
What did she do? What did she do?
She, you know how like the hoses with the Bunsen burners? While it was still on, she tried to take it off while it was basically. There's witnesses.
Carbon is black. Are we gonna
Just
start talking about the?
My watch, I wasn't talking
Okay,
about
no problem.
I feel like
This
you
is
said
alright,
this
this is
back.
alright.
Unexpected, so unexpected.
We're literally in 12th grade. We're going to college next year.
Are you really?
Next year, bro. It's in a couple of months. I didn't give away, it was them. Wait, what are they giving them now? About
He
this.
said it's,
He's like, can you just go?
he said it's the carbon black, and then Quinn was like, you know what else?
That was the other one. That was like, he's like, I'm trying to get it. He's like, can you get inside of the hole? And then he's like, because it's not even fun. This is why sex ed is important. Like, he said, why sex ed is important. One, two.
Yes, ma'am.
Wait, how many do we need? Just sorting. What are the Lego hands, Dr. Hennessy? They don't even fit
I think
how many Tell me this doesn't. Oh, never mind.
I think when you try to like
Buy
look at
it.
the hydrogen.
Yeah.
Look at it.
This is
I
hydrogen.
got it in. It has one little tiny. It's tiny. They're different.
So I'm trying to build it not quite from the bottom, so I don't have the CH2OH here. But here, these two are going back. These two are coming towards you. This is an H, this is an OH. Now these two are going back behind the board. This is an H, this is an OH. These two are going back behind the board. I'm gonna make this an OH and this an H.
Yeah, this is like a little enrichment activity.
Are we doing the room or are we doing?
Yes.
Can't do the fish wrong.
Yo.
How do you represent oxygen?
How do you represent oxygen with a color that is different than what you're using for hydrogen?
Okay. Isn't it white? Isn't it in the photos?
Hydrogen is traditionally white, oxygen is traditionally red, I think. Nitrogen is always blue. Apparently we're all racist, I missed exactly how that started.
Why yellow? Nitrogen is more of a green. Hydrogen is hydrogen.
I thought nitrogen was
Hydrogen is not clear.
Nitrogen, what colors molecules inspire to us?
No, not really. But like how I know this
Hydrogen?
for some reason.
Hydrogen is not, yes, one of my big points has been it's not actually planar, but we pretend it's planar to make that.
I think of like nitro boost and then
Yeah, I know I should have done this forever ago.
That's okay. I just did the. This is a pencil.
Oh, are you not supposed to?
It's not flat.
What's that? Look at it horizontally.
Actually, that would not make sense.
Is it meant to be like that?
Yeah, it's not clear.
No, I mean, with the hydrogen, it wouldn't make sense to have a bunch of carbon.
Opposite day.
Oh, you made
I thought. Why'd you say that? I don't know how to do anything else.
This is glucose. Oh, this is also glucose, yes.
So it has an O in one of the things.
This is real talent.
Yes.
Oh,
No, instead of one of the.
Oh, those are really hard to put together.
Oh, wait, look at this. Look at this. Yay.
Okay, wait.
And this is how it's supposed to
Burger,
look.
do you want oxygen to be blue?
Oh, wait, you're supposed to stick it in there?
Yeah, because it's I'm doing the alphabet. You just dropped the.
Oh,
Sorry, I dropped it.
Why is it so fast?
What?
No, this one. Like, why?
Wow, why is it so fast? Uh-huh.
No, I'm talking about like why is this side bigger than the other side? Does that make sense? Or is it just yeah? No, like why is this one bigger? Like this.
You have so much nail, I can't see poo. Okay, they're both the same.
Oh, are they? Oh, this one looks. Okay.
Size is elitism.
I don't have the skills. Just can't do it.
Oh my god, it's not coming out.
Would you like to explain why you're giggling?
Would you like to explain why you're
I'm giggling because you're giggling.
That's it.
Contagious.
He's that.
How do I just plagiarize for work?
What is it?
Are you racist?
Hope so.
Feels racial.
I'll make hydrogen.
Yeah, I just don't.
Oh, it's straight, if you look at it.
Yes.
Oh no, I don't want to do that. But I already made nitrogen blue.
Why is there nitrogen in your thing?
Oh wait, no, sorry. Good question.
Good question.
Did you say oxygen?
What?
Oh, you said oxygen.
Quinn, what class are we in right now? Which one
He
of
don't
those?
know. He's in like 20 sciences. He's just like, give me another IA, you losers.
Dr. Hennessy, I have a question for the CH2. For this one, when I watch it,
You just need a bullet.
oh, I need the
A white bullet.
Is that a carbon right there? Is that a carbon? Like, oh, okay.
What I claim is that if it's going up and down, it should be facing away from you.
There we go.
So for this one, I have these two facing away from me. So this is the bottom. I have an OH on the right and an H on the left. And now this one isn't oriented the right way, so I'm gonna have to rotate this molecule a little bit. And now this one has these two going away from me. It has an OH on the right and an H on the left. It has an H on the right and an OH on the left. It has an OH on the right and an H on the left. And then here I have that last thing. I suppose the O should be over here and the H is green because they're in the way. But it's not linear. You can imagine the ring closing by these two things attacking each other. That O maybe going into the ring right there. Actually, no, you can't. Right there. Yeah, I'm trying. And so if we didn't mess this up too bad. They were gonna do something
They
like
were-
that.
they were going to-
Close it maybe. We can't have it single, we can't have an SP2 hybridized thing. I think that's not true. You can go see if anyone else did it right.
Audrey, come back. We need the formula booklet.
This graphic is funny.
Oh, okay.
I'll tell you in a second. Of course you know it. Okay, so she's got
There's no more
alpha.
They're right there.
Who took them all?
Maybe
I looked at them, remember one. You took all the dark blue.
We can use the big balls for oxygen too.
Oh, really? Okay.
Yes. None of you made the straight chain. You guys are all stubborn humans. PR.
Give me something wrong.
No, you've never done anything wrong.
What color is your oxygen?
You're gonna have to do that.
I have 3 dark blues, but one on one.
Oh, I take it back.
carbon, and then these two hang off of this.
Doesn't matter, and then this
So it's supposed to
one,
be like
these are
this.
facing away from you, you have an H on the right and an OH on the left, and
Over.
oh, you don't have a double bonded O right now, that's the H that has the O.
unaware.
This is the H, this is an H.
I don't
C, H, C, double bond O, H. Do it elegantly.
No, I don't like this. I want to. No, for my
This green might have been better, to be honest.
Now you like,
Really,
you're taking the remnants of my corpse.
your core.
My corpse.
Okay, let's see if this is close. So I agreed with your structure, but if I make these two face away
Oh,
from
are
me,
the yellow
and I have an H on the right and an OH on the left, and I should not, they should be flipped. If I make these two face away from me, I should have an OH on the right and an H on the left, which I'm happy with. I should have an H and an OH. I should have it, so this one seems backwards also, maybe. Like this also seems backwards. I need an OH here and an H here. I feel like two of the chiralities are wrong.
She said so factual, non-captual.
Why
would you?
My phrase.
No, it shouldn't be afraid.
Yes, I know.
That's like
Telling me it's hard. I
blasphemy.
don't know if I can find a question I will. Apparently we all have a learn how to do it. I don't, if there is a question, I'm gonna find it.
Demographic of people like.
Watch it try.
Horniest way possible.
That
Why
demographic
is
of
it
people.
better biology than chemistry? Chemistry's a better subject.
No. Alex, also, so what do you say? Shit.
Oh, no.
That academic and demographic was
Just did great.
completely.
Nah, doing a 360 and then saying shit. I was like, wait, what? I had to do a double take. I was like,
Wait,
no,
Alex.
no, he texted me with like shit tripping. I was like, what?
Wait, which
Go
Alex?
back to the-
What?
Myers is not done.
Like his thing is
It's
grammar
because,
and.
it's because his friend.
But I thought you might get it back today.
It sounds like not even grammatically correct.
I didn't know if you knew anyone in first period.
Randomly just says
You know.
something and like, I don't know.
Really?
Yeah.
It's not offensive anymore,
It's
it's
not,
just.
but like, just randomly doesn't like.
I mean, Alvar and Gus and
It's
people
not my
like
place,
were
but that's
in that class, and Alvar's in Barcelona. So he didn't get it back.
You
I
get
think
your
it's slow
paper one, a paper, I think I did it. I got 96.
What's the
There's no double bond in the ring. Okay, so you have an OH down, an H up, an OH down, H up, H up, OH, OH.
How did you do the OH? I did my OH like this.
I literally represented the
No,
point.
wait. This one's OH, this one's OH, this one's
Let me
upside
finish
down.
the OA.
This one's a, oh, I drew it wrong.
Sorry.
Well, that sucks to suck.
So it's the.
Sorry.
So it's.
That's what you get for looking at the board.
H on the
Yeah, the third one's backwards, and you just had two in a row that were backwards. It's now perfect, I'll go fix my drawing. This wasn't glucose, everyone, this was mannose.
Oh.
I had no idea.
The blank hands?
Welcome on.
Just a different sugar, I don't know what it is.
I'm gonna make my OH prettier.
Your OH doesn't need to be
Is it really ugly?
You guys chemistry
What? What are they?
No, there's like a cat with my OH
So if you have a sugar or not, I need you to find the aldehyde or ketone in the sugar. And I need you to find the chiral carbon farthest from it.
Okay.
So we're gonna find the aldehyde or ketone in the sugar. We're gonna find the carbon farthest from it that is chiral. So I'm not looking at that. That's not chiral. How do I know?
It has two hydrogens.
There's two hydrogens. I'm gonna look at this one. And if the OH is on the right, it's D. Because it's on the right, and D means Dexter. If the OH is on the left, it's L. So there is L-glucose and D-glucose. The first chiral carbon opposite the aldehyde. Opposite the carbon.
Is the aldehyde on the top?
So here's another picture that has both of them next to each other. Since you can't see the top, so imagine that we have an aldose up here. Notice that it's the chiral carbon furthest from the aldehyde. If the OH is on the right, we call it D. If the OH is on the left, we call it L. This is still glucose.
Is there a reason that the H be bonded to the C on the second row instead of the O? Yay!
No, because someone has a typo.
Oh, so it's still OH.
It's OH. Yes, sir.
I was running this straight.
Yes, I was too. Yes. Yes. So when you're looking at this, you have some carbon issues. You see how this carbon has a flat line? That is an sp2 hybridized carbon as opposed to an sp3 hybridized carbon. So if you're looking at your angles, you're like, these don't quite make sense to me because I can sit this on the table. That's why things are a little bit wonky. But if we give that some grace, if these two are behind you, this OH is to the right, and this H is to the left, so you're drawing something that looks like this.
Let's do a little bit of compromising because people think I'm taking the
Oh, it just connected.
No, like the sp2 carbons can't make sp3 bonds. You need the other kind, or any other color. Only the carbons come in sp2. What? Yes. Yes. Mannose a monosaccharide? Oh, it is. Let's go.
Version of this, and you're doing
So you can look at mannose if you're in the mood, or if you're not, you can look at it still. And again, we're looking for the aldehyde. We're going to the chiral carbon farthest away. If the OH is on the right, it's D. If the OH is on the left, it's L. Can you name a ketose, fructose? Yes. So L means left.
Exactly.
Me.
Too late.
Like there's no corn method here. I know we all like the corn method, but. Okay, so I was threatened that maybe this wouldn't work for a ketose. So here is fructose, my favorite ketose. I look at the chiral carbon that's furthest from the ketone. If the OH is on the right, it's D. If the OH is on the left, it's L. This is the only change between those molecules.
This is the
Are ketoses the sugars that end in O's? So like fructose,
All sugars
sucrose.
end in O.
Oh, that's true.
Four. Gonna make that picture go away.
So just the last one.
It's the last one that decides if it's D or L. I know you. Hi. Hi, what's up?
I feel really threatened.
You feel threatened by Charlie Johnson?
Yeah. I'm really uncomfortable.
Don't make it weird.
I'm trying to be done with content forever and it's just going slower and slower. It does feel like giving up. So I was trying to put up the difference between mannose and glucose.
That one's.
They're all backwards too. It's the same picture. I mean, the internet sucks sometimes, right?
I like that.
Okay, I'm done with that. Going back to my Pearson second class.
It's a question mark. Yeah, no, just add the bottom part.
It looks like a hook.
Okay, so what I've been trying to tell you for a minute is that L and D are determined only by that singular carbon, and in nature we only have D. So just like all of your amino acids are L, all of your sugars are D. All amino acids are L in your body. The sugars in your body are D. should already know about alpha and beta forms of the ring. Alpha means the OH is down. It's drawn in the data booklet that way. You just need to know carbon 1 OH is going to flop. Same story for fructose. We're looking at the carbon that's next to the oxygen. That's what's going to flop. But this time it's carbon 2 because I have that unfortunate CH2OH because fructose was a ketone.
So alpha, the OH is down.
Perfect. Alpha, the OH is down on the carbon that's on the right in every picture in your data booklet.
That's the thing,
The application of this, so the application of pigments was hemoglobin. The application of this is vision chemistry. This is how your eyeballs work. In your eyes, you have rods and cones. Yeah. What do rods and cones see?
Rods, codes, color, rods, like darkness, black and white, and light, stuff like that.
Okay. I think that we get the name rod from the molecule rhodopsin. Also from the shape, you say?
I don't know, I thought that's what I thought all the time.
So apparently we take in vitamin A, which is retinol, and we change it to retinal. How do you think we change an all to an al? Okay, it's a redox reaction. I'm changing an OH to a double bond O, or I'm making an alcohol into an aldehyde. So it's oxidation. I don't have reflux in my eyeballs. You might. I have reflux in my esophagus. See, there's like a.
Haha, that's kind of funny.
You use sodium monohydride.
In your eyeballs? No, I use potassium dichromate. I have to oxidize it, not reduce it.
Oh. Oh.
So we oxidize vitamin A into retinal. Yes.
But that's not your
Right. Like, you didn't say anything wrong, I was making fun of you. Look, we don't have sodium borohydride in our eye either, like, same note. Al is aldehyde. Al. So my understanding of what happens is limited because I didn't study, because I had an interview this morning that was at 8:45, not 8:15. But you take retinol. I mean, she's like doing this with her molecules. She don't care no more. And when you oxidize it, you form it in its cis form. But when light interacts with it, light actually changes it to its trans form. So light has enough energy to like do this reaction, so it has to break a pi bond and rotate around and come to the more stable thing. But in so doing, a signal is sent to your brain because the shape of that enzyme has presumably changed. And that is when you see something, you're actually seeing because this has happened. The cis has become a trans. And then an enzyme, flips it back. So the reason that I thought you were going to tell me that this was in the colored portion of my visual cycle, I don't know, is because we did an experiment back in chapter 2 where I made you stare at something that was like yellow for a long time, and then I took the yellow away. Do you remember that at all?
Yeah.
What did you see? That's right, you see the opposite color, and my understanding of that is that it takes time for the enzyme to flip all the little molecules back around so you can perceive it again. So again, the energy of the light comes in, the energy is visible light, and so it's such that it's going to affect these double bonds and these long conjugated things that absorb colored light, because we've been talking about that for, a couple days now. And so then the visible light comes in, it flips this thing around, you're like, ooh, I see color, but it's going to take time for the enzyme to reset this so that I can see it again. So if you look at something yellow again, you actually won't be able to perceive yellow, because all of your yellow sensing molecules are tired and trans. Let's see if this picture helps. So can you see this as cis? Can you see the light has come in and changed it to trans? Good job, that's what you're supposed to see. Then we have to have an enzyme come and reset this. What is the name of that enzyme?
Maybe combine.
That was a fine guess. If I were you, I would read this story in the textbook. Or give me a minute and see if I have something else to say. But that is the last thing in our unit.
Do you know how to draw that? Or like know where the change is? No?
Bigger together.
Why are all these pigments? Tell you about boxes. So they can say, is beta carotene water soluble? Is beta carotene colored? How are alpha and beta carotene different? How would I say no?
Look at Chris.
Like
Let's
this
go look at this
one.
one.
Because
This is so-
it's no longer part of the alternating chain. Yeah, so I would say.
That's why he wanted to combine it with Moheb's.
Yes.
We're not combining.
That's a refusal. That's a
Separate, weird,
rejection.
and complete together.
That is so.
I feel like those are the kinds of questions we need to go on. They can say how many pylons. I gave you some practice questions on this because I knew today was going to suck. Because
I really like the molecule.
you're sweet, alright. Cyclic molecules, vision chemistry. Like the textbook doesn't say any more than a single sentence about this. You're done with all of the content in IB chemistry. We all knew this day would come. Just couldn't come fast enough, right?
Sub out.
Giving you Ron said, Lori, yes.
Should I end the video? Probably, right?
Yes.